Tomorrow will be better. Define the possible transformations in the function this. Dear friends, let me start by saying that when it concerns transformations, it's very important to understand all the transformations that exist and most importantly to know each of their equations, all right? Now, what is this question saying? They've given us a certain transformed function. And what they're asking us to do is to find the original function from which this thing came about, and most importantly, to find the mechanisms that happen to that original function for us to obtain this. All right, follow me, dear friends. Let me show you what to do. Solution. Now, if you've understood and you've mastered all the equations that accompany each transformation type, then just looking at this right up here, you will understand, you will suspect that this looks like some sort of a translation. Now, let me suspect a certain original function as g of x equals to x squared. So I'm going on a suspicious basis that suppose my original function was g of x equals x squared. Why do I write x squared? There should be some guidelines to what you're suspecting. I'm writing x squared here because in the transformed equation or in the transformed function, I can already see a certain term here which has been raised to the power 2. Okay, so there should be a power 2 in my supposed original function. Now, like I suspected earlier, that this looks like a translation. Why? Because according to translation formula, if we have a certain function h of r, then the transformation h of r plus a certain k is what we call a horizontal translation, either k unit to the right or to the left, depending on the sign of k. If k is positive, then we have a horizontal translation by k unit to the left if k is positive. But if k is negative, then we have a horizontal translation by k unit to the right if k is negative. Now, how do I make this my original or my supposed original function to look like this? Clearly, from here to here, it means we've simply had to do a certain g of x minus 2. What is g of x minus 2 if this is our supposed original function? It means you come to this function here, each place you find x, replace it by x minus 2. So let's do this here. So we will have, this is the only place you have x here, so you replace it by x minus 2. And of course, let's not leave out the square. Oh, bingo, this is what I was suspecting. So you clearly see that to the original function g of x, we have added a certain constant k, which is negative 2. Therefore, the first transformation that has occurred here already is that we've taken the original function g of x and we've translated it 2 units to the right. Why to the right? Because the value of k is negative. Now, for the next transformation, which we are about to evaluate here, we will use g of x minus 2 as our new original function, okay? Now, again, with our mastery of the equations that accompany each transformation type, we can already observe this and see that we can live from here to here by simply adding a 4. Now, if this is really what we're suspecting, then it aligns with the formula according to which if we have a function h of r, then the transformation h of r plus a certain k is what we call the translation of this function h of r, either k unit upward or k unit downward depending on the sign of k. Now, if k is positive, we will say the function h of r has been translated or has been shifted k unit upward. But if k is negative, we will say it has been shifted k unit downward. As we can clearly see, we are suspecting that our k here is 4 and 4 is positive. Therefore, how now do we get from this new original function g of x minus 2 to obtain this? Of course, we just come here and we say g of x minus 2 plus 4. Let's evaluate it. What are we going to obtain here? Clearly, we will obtain, let's start by writing first of all g of x minus 2, which is x minus 2 all square, and now plus 4 plus 4. Okay, there we go, dear friends. Therefore, we will observe in conclusion that the function, because clearly this, I will say here that which is equal to f of x. This is the magic of it, dear friends. Therefore, we've gone from a certain function g of x, which is x squared, and we've carried out the first transformation, which turned out to be a horizontal translation or a horizontal shift 2 units to the right. And to this new function, we did another transformation, which turned out to be a vertical shift 4 units upward. Okay, so in your final answer, this is how you're going to represent, or this is how you're going to write. We will say that the function which they gave us, f of x, is actually a certain original function g of x, which we've already defined here, which was first of all translated horizontally 2 units to the right, and next was then translated vertically 4 units upward. And this is how simple it is, because tomorrow will be better.